Okay guys, just wanted to give you a quick update here on the progress I've made in the design phase here. I know this sort of contradicts what we've done with the design video already, but just to give you an update, as you know, these things just kind of change as you go, even though I commit it to video. So one big change here, notice that the unit actually is going to have hinged doors now instead of the sliding doors like before. But still pretty simple, straightforward design, nice big fat bevels on the top and bottom. This will be composed of 2 sheets of plywood glued together to give you a nice 1.5 inches or roughly 1.5 inches thickness. The other thing that I posed on the website recently was the question of how to deal with this really undersized plywood. Let's say you're doing a dado, like this stop dado down here. You use a 3/4 inch bit, that's going to be too big. You use even an undersized plywood bit at like 23-30 seconds, that's still going to be too big. So you have to use a smaller bit and do multiple passes. And of course there's a lot of jigs and little gizmos out on the market that will do that for you, and you could certainly make something in the shop, but I really didn't want to focus on building a jig for this. I really wanted to come up with another solution that didn't involve, what would basically amount to a whole nother episode dedicated to building a jig. So there was a suggestion in the comments, I thought it was a good one, and that's what we're going to go with, is trimming each of these pieces. This is one of the side pieces here. You'll notice that would go into one of the dados, the stop dados in the bottom, or also the top as well. What I'm going to do is trim a little bit of material off of both faces so that we're left with a tongue that's a consistent thickness. In this case, I have it mocked up here at 3/8 of an inch. So of course I have a 3/8 of an inch router bit. I could do it in one pass and this should fit perfectly. And I'm of course going to cut the tongues after my grooves and dados are cut so I can make sure that they fit perfectly. So that system is going to be used consistently all the way around this thing. Now since we're losing a little thickness as far as the width of what's being penetrating the bottom and the top pieces, what I want to do is get a little bit more stability and strength out of that. So instead of going, what I normally do, which is about 3/8 of an inch deep with these dados here, I'm actually going to go a full 1/2 inch, and hopefully that'll give me a little bit of extra strength. Now notice here too, see the little notch here at the bottom? These stop dados down there are going to be notched. Okay, and this way, it sort of just hides the joint a little bit better. So it's got a little 1/2 inch notch back there that should fit in perfectly. The left compartment will have shelves. As you can see, I haven't really put the shelves in. This is a center partition, and I did kind of mock up some of the locations for the shelves. Notice that the center partition here is actually going to have to be, well, you might see it from this view better. It's going to have to be a different width from front to back. You see the back panel spans the entire distance, which I don't know if you look closely at the model that I have over there, but I wasn't able to get it to look the way I want it to look. So the reality is the back panel spans the entire distance as one full sheet. So this middle partition has to be dadoed into that back panel. So the actual width of this is going to be less than the 2 side pieces. So that's why I've got a side piece mocked up here, and then I've got a centerpiece mocked up here. And on the side, I just decided to play with sort of doing a general cut list or a diagram so I could see what this is actually going to cost me in terms of material. And there's no way around it. You got to use 2 sheets. How you position these to get the most out of it so that you have some material left over for other projects, you might be able to play with it and get it a little bit better than what I have here. But this is probably how I'm going to jump in the shop and go for it. I've got the back panel here. There's the 2 side pieces. Right here is the center partition. These are 3 shelves. This is one of the top pieces. There's a second top piece, 1 bottom piece, and a second bottom piece. Because remember, these are going to be glued together to get that extra thickness. So this is what we're dealing with here. Since this is odd-shaped plywood, if you take a close look, what I've done here is marked center points. I'm not so concerned about where the start of that, where the start of this groove and this, or actually this dado, is going to be. I'm concerned where the center of it is, because this plywood's just not consistent thickness. I don't trust it. So I want to know where's the center. That's where I'm going to center my router bit, which is going to give me a 3/8 of an inch groove. And then when I put a centered tongue at 3/8 of an inch thickness on the end of these pieces, they should drop right down. And there's a few things we're going to have to get the measurements for after we already construct some pieces. Primarily, this center partition from front to back, that's a width that is only going to be obvious to us later. And then also the total length of the back panel from one side to the other is something that might have a little bit of variability that we have to watch out for. So we'll cut those rough, we'll cut them oversized, and then this way we don't chance, cutting it too short. So that's the plan as it is now, Stan, and it's Friday night, my dinner's on the table, and I'm gonna go eat it. So today we're going to start the wall hanging tool chest project, and the primary material for this project is going to be Baltic Birch. Now Baltic Birch, if you're not familiar with it, is an incredibly stable plywood. Really, as far as the substrate goes, it's one of the absolute best. Very stable, composed of a bunch of even and consistent thin layers of birch, and the faces are pretty clean for the most part. So it's about $45 is what I paid for these 5 foot by 5 foot sheets. Kind of an awkward size to transport around, so you might want to bring a saw with you, depending on your vehicle. But 45 bucks a sheet is really not too bad for something that's this stable. Now, this stuff is actually really popular for cabinetry, mainly for like kitchen cabinets and commercial manufacturing, because number one, it's widely available, it's very stable, but the edge here, the end grain, does not look as ugly as it does in other types of plywood, because it's even and consistent all the way across, and the alternating grains. Remember, plywood is typically one layer running this way, one layer running that way, one layer running this way, and it alternates, and that's what stabilizes it. But it also creates this alternating pattern of light and dark on the end grain, which is, it's certainly not the worst thing in the world to look at. So I want to take advantage of that and use that in this project with no solid wood trim on these edges. I just want to kind of leave it out there and see what it looks like. Hopefully it won't look like crap, but we'll find out. So a couple little factoids about Baltic Birch. It's also known as Russian birch. If you see something called Finnish birch is actually very similar to Baltic birch. It's just that the adhesives used to make the material make it better for outdoor use. They're water resistant. And the other variation that you might see of this is the American version of Baltic birch, and it's usually referred to as apple ply. And instead of all birch, it's alternating layers of birch and alder. And you could have various different veneer faces on top of it as well. Now those are typically sold in a standard 4x8 sheet, so if you see that around, it might not be a bad idea to pick some of that up as well, because it's going to look very similar when you look at the end grain. So there's a little bit of information for you. I think we're ready to get started and jump right into the project. All right, so the first order of business is to take our cut list and to start chopping down that plywood into more manageable sizes. And in fact, we're just going to aim for what I consider to be the rough sizes of all these pieces, and then they're all done and ready to go for later in the project. Now, when I do this, I like to do it in the most back-friendly way possible. A few years ago, I actually injured my lower back, and it seems like if I just pull something a little bit too heavy or just pick it up the wrong way, I wind up re-injuring my back, and I know I'm not the only one. So let me show you how I handle this stuff, and hopefully it'll help you out in your shop as well. So let's get started. So the first thing I'm going to do is lay down a couple of 2x4 supports. You could also use a big piece of foam insulation. I know a lot of people recommend that, but you've got to have a place to store that foam insulation when you're done. I don't, so I just go for the 2x4s. You just get the piece in position here. This little contraption, by the way, is called a Gorilla Gripper. It's not that expensive, and this thing is really going to save your back. It's really simple the way it works. It just hooks on and then kind of grips on its own, and then now you can use your legs to lift the workpiece instead of using your back. And man, let me tell you, this is really, really going to save you some backache. So check that out. Now, in this position, the good thing here is I don't really ever have to lift the full weight of the sheet with my back. It's all with my legs. And a lot of people like to cut on top of sawhorses, but you got to get it on top of the sawhorses first, which can be a pretty big challenge, especially if you're alone. So at this stage, all I really need to do now is just let it down. And now I can work on my layout. Now you probably noticed in the drawings that the top and the bottom of the tool chest are pretty thick. And the way we're going to get that thickness is by gluing two pieces together. Now when you do this, make sure you mark two faces as glue so you don't get them mixed up. And with Baltic Birch, a lot of times there is one face that has those sort of football-shaped repairs on them and one side that's nice and clean. So of course you want the pretty side out, put the two ugly faces together. Now to glue these together you need a nice flat surface, and my workbench is perfect for that. But if I put the piece like this, I can't get a clamp to this inside edge. I just don't have a clamp with a wide enough mouth. So I've got my bench away from the wall, and I'm going to skew the piece so it's from the corner to this area over here, and now I'll be able to reach a clamp that far. There's a few other things that you want to do, because gluing this surface down is kind of like veneering without a vacuum press. You want to make sure that you get a nice even distribution of pressure. So one thing we're going to do is use another piece of plywood on top with no glue. And just by doing this alone, this helps distribute pressure wherever we have a clamp. But we still don't want to just put a clamp here, 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 and here. It's really not going to distribute it well. The center is going to wind up lifting if we do that. So what I suggest doing is using a cambered caul. Cambered cauls are nothing more than a stick of wood with a nice curve in them. The idea is the center makes contact, and as I clamp down the ends, it not only puts pressure on the ends, but then puts pressure in the center as well. So when it's all said and done, you've got nice even clamping distribution all the way across with two clamps. So if you're kind of lazy like me and you don't feel like making these things, you can buy them. This one is made by the Bow Clamp Company. In fact, I don't know that anybody else even makes these things, but they do a really great job. They're not that expensive, and if you'd rather just be building than making calls, this is a good option for you. So that's what I'm going to try out today. So this is going to be one of those projects where we don't really have all the information that we need right up front. Some of the stuff I'm going to have to get from the project itself after some joinery is cut and we've got some partial assemblies together. So while the top and bottom are cooking in the clamps, the only thing we can really do right now is cut the side pieces. So I'm going to do that right here at the table saw, and I'm going to trim them to length over at the miter saw. Now before making my cuts at the miter saw, I decided to take one last look at the cut list and make sure I didn't miss something. It's a good thing that I did, because I realized that the center partition piece has to be the same length as the sides. It just makes sense. Now we don't know the width of that center piece yet, and we don't need it right now, but if I at least get the length cut exactly the same as the sides, I'm going to save myself a lot of headache. So when you're cutting pieces all of the same size, you have a couple ways that you can do it. You can use like a repeatable setup with a stop block and cut each one individually. Or in this case, I only have 3 pieces at 3/4 of an inch thick each. Why not just bundle them together? So I've already made one cut on each piece on one side to square it up. I bundled those together, use my fingers to determine that they're perfectly flush, clamp them together, and now I make one clean cut on the side, and they'll all be exactly 24 3/4 of an inch. Now you may notice toward the back here I got a little bit of tear out. Now normally on most miter saws I will put a strip of material, typically like a 3/4 inch material, sheet good, on the back, and that supports the fibers in the back and kind of creates a zero clearance. Well, this saw is actually brand new and I haven't had a chance to really whisperize it yet, so we'll do that in the future. But the reason I'm not concerned about it right now is because I'm going to be cutting joinery on the end here. So any little bits of tear out, they're going to be gone. So I let the top and bottom pieces dry overnight, and now we're ready to trim them to final length and width. But before I do that, I need to create one clean edge, because I've got all this glue squeeze out and the boards are a little bit uneven. I cut them oversized because I knew they would slide around a little bit. So I'm going to use the Festool track saw to do that. And you know, if you're getting your knickers in a twist because you don't have a Festool track saw, remember this is easy enough to do with even just a piece of wood as a guide and a regular circular saw. I covered that in the Entertainment Center, the Low Entertainment Center series. I believe it was episode 1, where I showed how you could use that to do a very similar operation to what we're doing here. But for me in my shop, I've got it. I'm going to use it. It works great. but just know that you don't necessarily need this expensive stuff to get the job done. Now we're at a very critical part of this project. We have to transfer our layout marks for our dados and grooves to the top and bottom pieces. So what I like to do here may be a little bit different than a lot of people do it. I like to go based on center lines. And some of the measurements aren't quite known yet because they're dependent on the thickness of the material. Personally, when I see a plan made out of plywood that gives you exact numbers, it's a recipe for disaster, because if you follow those exact numbers and your material isn't the same thickness as the person who wrote that article, you're going to wind up in a situation where things are either too big or, worst case scenario, too short. So what I like to do is focus on the layout of the center lines, because most routers have a little tick mark or something on the base that indicates where the center is. So it's very easy to line up your bit dead center. It's a lot harder to line up a bit directly to the outside of that line. You know, it may be a personal preference, but it just seems to make a lot of sense to me. So with a plywood plan, I would build it so that the user has to, kind of use their head and decide, okay, here's the center line. Now, depending on the thickness of your material, that will dictate, let's say, the length of the shelf that goes between these two pieces. It's something you just can't know until you have the thickness of your material down and you've got the material on hand. So based on that, I've got some materials here that are going to help me line up my cuts. Some things I just couldn't answer until right now. So first of all, let's look at the side partition piece that's going to go in here. I want that located in 1.5 inches from the edge. So I'm going to draw that in real quick. And then this piece is going, let's just say this represents one of the side pieces, that's going to line up right on that edge. So now what we need to do is transfer the center line. Okay, so we know exactly where the side needs to butt up against, but I want to make sure that we get the center of this piece so I can line up my bit. So what I've done is taken a piece of scrap and I drew a little arrow and a line that represents the center. The good thing about this Baltic Birch is there is a center ply. That's pretty much the dead center of the workpiece. So I just marked it with a pencil, put a little, arrow there to kind of give me a little visual reference. Line this up with my pencil mark. In fact, if you want, you go ahead and use a square to make sure it's nice and straight. Right on that pencil line, and now I can very easily transfer my center line to the workpiece. Now when extending this line, instead of putting my square in the back or in the front and extending the line all the way down, I'm going to set my adjustable square here to the right spot, and I'm going to use that, and I'll show you why in a second. I'll extend my line this way. Perfect. And the reason I do that is because on this side, I don't want to go through the trouble of remeasuring, then using this center guide piece to place that mark there. What I want to do is have an exact repeatable mark. See, that process has some natural variability and error built into it. So once I lock this down, this is a metal square. This is not going to have a whole lot of variability. So I could just take that over to this side and I can put my mark there without any measuring. So now let's look at the location of the back panel. The back panel is going to be set in approximately 3/4 of an inch, but it's not exactly 3/4. What it really is the thickness of one piece of this material. The French cleat is going to be made with this material, so it has to be exactly this thickness. So I use this little scrap piece as a guide. I place that straight up against the back, and that represents the cavity or the area in the back where my French cleat would live. And then I grab my workpiece with my little arrow on it, and this is all by hand. You'd be surprised at how sensitive your fingertips are. And when I have it perfectly flush, now I can transfer that center line to the workpiece and extend it all the way across. And for the center partition, all we need is the dead center of the board. So that should be 21 5/8. What I like to do is put a pencil mark representing from the left side, and I'm going to measure it also from the right side. So if there's any variability there, we'll be able to see it this way. And this one looks dead on. And now I'm just marking the locations, the front basically of the stop dado, which is going to be 4 inches from the front and 7 inches from the back. This is just a visual guide to let me know where to stop when I'm doing the routing. Now I'm also going to make those marks on the other piece. And that way I have my visual reference there as well. And most of these cuts, after I make them on the first piece, I'm just going to take that same setup and go over to the second piece. So I don't necessarily need layout lines other than lines that tell me where to start and stop for the dados. And now the last thing I'm going to do before we actually make our cuts is what I like to call the sanity check. I'm just going to take my workpiece and I've drawn my little notch on the bottom and I want to line it up with the work and just make sure that everything looks right. You know, at this point you just don't want to make a stupid mistake, and it's very easy because really it's all concepts and theory right now because it's all lines drawn and paper diagrams and things like that. So putting the workpiece onto the piece you're about to cut is really the best way to just give yourself that little sanity check. So here's our stop dado. That's where our notch is going to be located. And I feel pretty confident to move forward. When you're sizing the bit for the workpiece, if you're creating a tongue and using the joinery system that I'm using, you want that bit to be as wide as possible without exceeding the thickness of the material. Now for me, I would say 5/8 is probably going to be appropriate. Well, here's the problem. I only have a 1/2 inch. It's not too bad, it's not the end of the world, and I need to get this project moving so I don't have time to order one and go through that whole thing. So I'm just going to go with the 1/2 inch. But if you think about it, if you go too thin on that tongue, you're really going to weaken the joint and weaken the tool chest on the whole. So go as wide as possible. If you have a 5/8, go for it. But again, I'm just going to stick with a 1/2 inch. So let's mangle some wood. So now we're going to cut the tongues. Now remember, there are actually 2 different tongues in this project. One corresponds to anything that is going into the bottom or the top piece. Those are extra deep, but they're actually at a 1/2 inch. So basically the top of the side panel, the bottom of the side panel, the top and bottom of the center partition, and the top and bottom of the back panel all get that 1/2 inch long tongue. The other tongue will be 3/8 of an inch. Those are the ones that are in the horizontal dimension. So, you know, because this is thinner, I don't want a full 1/2 inch tongue going into this, so this one only goes in 3/8. So we'll start by making the 1/2 inch, and then we'll make the 3/8 after that. But one thing we have to dial in is the thickness of that tongue. So we'll start with the 1/2 inch long ones. So all I'm going to do is just make sure that I'm set at a 1/2 inch. And what I've got here is my dado blade, and I've got enough chippers in there to bring me just over a 1/2 inch. And this way I could bury it into the fence using the sacrificial plastic fence, and then I could run my pieces right up against the fence and get that nice rabbet on the edge. So I just made sure I have a 1/2 inch of the blade exposed, and now I just need to make some test cuts with scrap. And what I'll do is slowly but surely sneak the blade up. And remember, every time you raise the blade, you've got 2 passes. Okay, so each time you raise it, the effect is actually double in terms of what you're taking off of the material here. So I will make a cut, I'll test fit, cut again, test fit, and that's why I've got everything right here so I can make sure I get it exactly where I want it and I don't overshoot. So let's start making some test cuts. Now I know we already measured and marked for the back panel, but I didn't actually cut the piece yet. And part of the reason is because you can wait till the dry assembly to get an even more accurate measurement, and that's what I'm going to do. So I just have a metal ruler, I butt it against the inside of one piece and measure the distance to the inside of the other piece. That inner dimension isn't the length we need because remember, we've got these grooves and we need to cut that joinery there. So what I like to do is add 3/8 per side because it's a 3/8 of an inch deep groove on both sides. So take this total number and add a total of 3/4 of an inch to it and you've got the exact width. And I really don't know of a more accurate method than this. So now I want to work on the 3/8 inch tongues. It's really the same exact process as the 1/2 inch. I just butted the fence in a little bit so I don't take quite as much off the edge, and I adjusted the height slowly until I get the perfect fit. And I've got one of my side pieces here just for testing. This is a little piece of scrap that I used, and that's perfect. That's a slip fit. And in case we never talked about this before, I think we have, but a slip fit is basically something, a joint that goes together without a hammer, but holds itself together, you know, against the force of gravity, basically. That's a slip fit. So we're ready to go. Now at this point, this joint gets put onto the sides of the back panel and the back of the center partition. Now the back panel is going to receive a dado in the dead center, and that's for that center partition. Now to do this, you can use the router, set up a straight edge, and go that whole route, but since I've got the dado stack in the table saw, all I had to do was resize it to an exact 1/2 inch and get the blade to the right height, and with one pass I can have this dado all the way down the center of the panel and it'll be nice and consistent all the way through. So it's kind of the lazy route, but the results are going to be just as good. So let's make that cut. All right, we'll just test the fit real quick. That's nice. Perfect. Now, I know I just said perfect, but I lied, and I want to show you what happened. The dado is perfect to about, I would say right about in this area here. I think the board might have just a little bit of a bow to it, and it lifted a little bit at the back end of the cut. And that's okay if you have the right tools to fix it. You could just take another pass right at the table saw, but the problem with that is if I'm even slightly off, I'm actually going to widen this dado and make it a loose fit, and I don't really want to take that chance. So this is where one of these, you know, hand tools just really helps. In this case, the router plane is probably one of my most used hand tools in the shop. So all you really need to do is set it to the depth that you know is right. And this is, I mean, this is dirt simple stuff here. There's really no user error is even possible here. Just keep pushing forward. Okay, and when it's all said and done, it should be nice and even now. Now I'm dropping in the back panel here and I'm doing one last dry assembly because I want to make sure that the center panel is cut perfectly. There we go. So now that we have the back and the sides installed, we can measure for the center panel. Now my tongue is already cut here, so when I remove material from the center partition, I'm going to remove it from the front. And I kind of jumped the gun. I put the notches there already, but we could always just use a chisel and a small saw and remake those notches, so that's no problem. So I'm going to push it all the way back into the dado, and I got a neat little trick here. Since I want all of the fronts of these pieces to be even, equally distant from the front of the workpiece, all I need to do is put a steel ruler up against my two sides, tilt the ruler up, and then just transfer my mark. And that's how I know where to cut. Now just because we're not putting any solid wood on the exposed edges here doesn't mean that we shouldn't do something to beautify them. So what I'm going to do is put a double chamfer, one on each side, just a very little chamfer across the edge that eases it, makes it look a lot more attractive. As you're putting your hands into the cabinet, you don't have any sharp edges to worry about, and it also makes it less likely that that veneer on the outside layer is going to get caught on something and peel off. So very simple operation at the router table, but before I do it, I'm going to mark all of my corners with a Sharpie just so that I don't get mixed up. And the reason is, I don't want to do the outside edges of the side pieces because I'm going to have to put a hinge there. The whole thing's going to get kind of weird. So I really only want the inside edge to be done there. I'm going to mark that so I just can't screw it up. And it's not a bad idea, of course, to do the back as well, and that way it just is a little bit easier on the hands if you go to move this thing around. So let's talk about these big honking bevels here. Now there's a couple ways that you can make this. It depends on what tools you have in your shop and what you're comfortable doing. First of all, you could tilt the table saw blade to 45 degrees and you can cut them that way. You're going to have to be very careful when you cut the ends though. You probably want to use some sort of a miter gauge and clamp it all down and make your cuts that way. You could also use the miter saw. Tip the bevel down to 45 degrees. Just make sure you mark on the fronts and the back so you know exactly which way to make that cut because you don't want to make it on the wrong side or on the wrong angle. You can also use a circular saw. Most circular saws, well, all of them really, should go to 45 degrees. This can create kind of a tricky cut because we're not going right to the edge with our cut here. We've got that little half-inch lip at the bottom. So that might be a little bit tricky, but there's at least 3 or 4 different ways that most of us are capable of making this cut in our shops with a standard set of tools. So really just depends on what you're comfortable with, but either way, get the best results you can and then come back either with a block plane, maybe some sanding just to clean up that edge and make it look real nice and stop any of the little splinters that might have resulted from poking out and grabbing your finger. So let's turn our attention to the shelves. Now the left-hand side is the only compartment that's going to have shelves in it. So what I have to do is concern myself with the joinery on the left-hand side wall and the inside of the center partition. Now originally I was going to put the shelves in and dado them all the way around in the back panel and the sides and everything. That would have been a huge pain in my butt, and I'm glad that I figured out a better option. And part of the justification for this is the fact that sometimes I don't really even know what's going to be on those shelves. So wouldn't it be nice to have them be adjustable? And guess what? Adjustable shelves are a heck of a lot easier to install. So what I'm going to use is standard 1/4-inch holes, and I'm going to use these very industrial metal shelf pins. Okay, and they can hold a lot of weight. They sit in there really nice. It's going to look fine. It's going to be fully supported, and I have the added advantage of adjustability. What I'm going to use to make them, you've seen me use this before, is the little rockler jig. It's really not that pricey and it's a great investment. So all I have to do is reference off of one side and do that consistently on both pieces, and I'll have my shelf pin holes in the right place every time. So now we need to sand everything. And keep in mind, when you sand, you're going to lose all of your reference marks that you may have written on your boards. So here's a little tip. Just write them on your tongues and tendons, and that way they'll still be there even at the point when you're assembling and adding all of your glue, and you won't screw anything up. So for the sanding, I'm going to start with 80 grit and move up to 120 and finish with 180. And the good thing about Baltic Birch is you've got a nice thick layer of veneer on top. So you don't have to be quite as careful as you do with most hardwood veneered plywood that you might burn through. This really, you don't really have as much of a risk, but clearly don't go crazy on it because you can still burn through it. The other thing I wanted to mention is that I am going to assemble the case, and then we're going to worry about the doors after the fact. I want to get the case together and just kind of get a better visual for how things look because I haven't 100% decided exactly what I want those doors to look like yet. So let's get our dust mask on and start sanding.